Okay, we are now going to be using matrices to help solve systems. And we're going to use the multiplicative inverse that we found yesterday in order to undo the equation and get just to our answer matrix. So there are 3 steps. First, you have to write the system as a matrix equation. Then you'll find the inverse of your coefficient matrix, and you'll multiply each side of the matrix equation by the inverse, making sure you put that inverse matrix in front. So first off, we need to write this as a matrix equation. To do that, I have one matrix for my coefficients, one matrix for my variables, because if I multiplied those, I would get 2x plus 3y, 1x minus 1y, and then equals, and then a matrix for the constants up here. So this is step 1. This is writing my matrix equation. Step 2 is to find the inverse. So if you remember, to find your inverse, first off, you find your determinant, so that'd be -2 minus 3, so -5. So my inverse matrix is going to be 1 over -5 times, I switch my A and my D and change the sign of the other two. So when I multiply that, I get 1/5, 3/5, 1/5, -2/5. Step 3 says multiply your matrix equation by your inverse, making sure to put the inverse in front. So here's my inverse matrix. Times my matrix equation. Here's the left half. Since I have to multiply both sides by that inverse matrix, I'm doing that, but I need to make sure I put that inverse matrix out front, since multiplying matrices is not commutative, so the order does matter. Then I'm going to start multiplying, and I'm actually going to write my answers up here. So on the left side, I should end up with a 2 by 2 matrix times my xy equals, and on the right side, I should end up with a 2 by 1 matrix. So on the left side, I do 1/5 times 2, so that's 2/5 plus 3/5 is 1. 3/5 plus a -3/5 is 0. For the second row, I have 2/5 minus 2/5, which is 0. And then 3/5 plus 2/5, which would be 1, which is my identity matrix. So this is really just going to, when I multiply it by xy, it's just going to cancel out. Over here, I have 1/5 times a -17 plus 3/5 times 4, so that's 12/5. -17/5 plus 12/5 should be a -1. For the second row, I have -17/5 plus a -8/5, which would be a -25/5 or -5. So what that means is x equals -1, y equals -5. Second example, Start with rewriting this second equation so that it is matching the first one with the x and then the y and then the equals the number. So that should be 2x plus y equals 5. When you write your matrix equation, it's going to be -5, 1, 2, 1 times x, y equals -2, 5. From there, you need to find your inverse matrix. Just first as a hint, or as a check, your determinant should be -7. So go ahead and find your inverse matrix. It should be -1/7, 1/7, 2/7, 5/7. You are then multiplying this matrix by both sides up here. Make sure you show me the setup for that. And then go ahead. So x equals 1 and y equals 3. Over here, you're starting the same way. Go ahead and get your matrix equation written. Once you have that written, you need to find your inverse, and you start that by finding your determinant, which would be 6 minus 6, which is 0. So since there's no determinant, there's no inverse, so my answer would be no solution. And just so you can see what that looks like, if you were going to solve this typical way, maybe I put them into y equals form so that I can graph them. So here I get y equals -1/3 x plus 0. This one I get y equals -2/6 or 1/3 x plus 5/6. Their slopes are the same, so these are actually parallel lines, which is why they have no solution. So when you're doing them graphically, you get parallel lines. If you were solving by substitution or elimination, you would get 0 equals 5 or 3, or just two numbers that are not equal, so that'd be no solution. Or when you are doing them with matrices, you have a determinant that equals 0, so that means that there cannot be an inverse. That's how you know it's no solution. Okay, the next examples, still the same way, they just have 3 variables. So we're going to be able to use our calculator a little bit. You still have to show work on your paper if you want any credit. So we start off by writing our matrix equation. This time this will be x, y, z. Notice that these variables go in the same order that they appeared over here. Once you have done that, you can start using your calculator. So you will go to the matrix menu on your calculator, go over to edit, and you will input this 3 by 3 matrix, and that's the first thing it asks for is the dimensions, and then you'll input each row. Go ahead and do that. Now that you have done that, go back to your matrix menu to where it has the determinant and hit determinant, then go back to the matrix menu, and in that first section just hit 1 to select matrix A, and then hit enter, and it'll give you your determinant of A, which is -13. Go back to your matrix menu and select matrix A, and then press your inverse button on your calculator. It will give you your inverse matrix. Go ahead and get that written down. If you're having trouble getting it from the decimals to the fractions, remember, just press math, enter, enter, and that will put it in a fraction format for you. So now I have my inverse matrix. You then need to multiply this inverse matrix times your solution matrix up here. And you will need to put that second matrix into your calculator as B. So go back to your matrix menu, go over to edit, go down to the second matrix. You're putting in this 3 by 1 matrix, enter each row, hit enter. When you're back on your, so quit out of there, when you're back on your main screen, pull up that inverse again, so go to your matrix menu, first matrix, and then inverse, and then you're going to go back to matrix menu, second matrix, just hit enter and it will multiply them. When you do that, you should get 1, -4, 4. So there's my answer matrix, which means x equals 1, y equals -4, and z equals 4. Again, with the 3 by 3 matrices, you are allowed to use your calculator. You have to have at least this work. So this is the bare minimum on what must be on your paper if you expect to receive credit for it. Last one, start by writing your matrix equation. Since this is a 3 by 3 matrix, you can go ahead and put this in your calculator. Make sure you are telling me what the determinant is, what your inverse matrix is, and then what you get when you multiply your inverse matrix by your solution matrix up here, or matrix B. You will need to do all of that, but just as a check, your final answer matrix should be 1, 5, -3, so x equals 1, y equals 5, and z equals -3. Just as a side note, it would be sufficient to write your answer as x, y, z equals 1, 5, -3. You do not have to write them out like that.